Switch VLAN configuration. Today's experiment aims to observe how switches partition VLANs and how to configure VLANs. The objectives of the experiment are as follows. 1. Understand virtual LANs, VLANs, and their basic configuration. 2. Master the configuration method of dividing VLANs based on switch ports. 3. Master the configuration method of tagged VLANs. Experiment background. Suppose a company's finance department and sales department PCS need to communicate through two switches. It is required that PCS in the finance and sales departments can communicate with each other. But for security reasons, they need to be isolated from each other. To achieve this goal, appropriate configurations need to be made on the switches. Technical principles. 1. VLAN refers to the logical division of a physical network segment into multiple virtual LANs. VLANs offer the advantage of flexible partitioning without being limited by physical locations. Hosts within the same VLAN can communicate with each other, while hosts in different VLANs require routing devices for communication. Broadcast data packets can only be broadcast within a VLAN and cannot be transmitted to other VLANs. This is the first aspect of the technical principles. 2. The second aspect of port VLAN is one of the methods to implement VLANs. It uses switch ports to divide VLANs, where each port can only belong to one VLAN. 3. The third aspect is tagged VLAN, which is another type based on switch ports. It is mainly used to enable direct communication between hosts in the same VLAN while isolating hosts in different VLANs. Tagged VLAN follows the IEEE 800 and 2.1q protocol standard. When data transmission is performed using configured tagged VLAN ports, 4 bytes of 800 and 2.1q tags are added to the data frame to indicate which VLAN the data frame belongs to. This facilitates accurate filtering by the destination switch upon receiving the data frame. In other words, after adding the tag label, hosts within the same VLAN can communicate with each other across switches. Let's take a look at the steps of the experiment. First, we need to create the topology diagram using Packet Tracer. Next, we'll divide the VLANs. Then, we'll assign the ports to their respective VLANs. After that, we'll set up tagged VLAN trunk mode, which involves adding tag labels to the trunk ports. Once these steps are completed, we'll proceed with the testing phase to check if communication is possible between hosts within the same VLAN, and restricted between hosts in different VLANs. For this experiment, we'll need the following equipment: 2 layer 2 switches, 4 PC machines, and several Ethernet cables. The topology diagram shows that 4 PCS are connected to 2 switches, and the 2 switches are interconnected through the F024 ports. VLAN 2 includes PC1 and PC3, while VLAN 3 includes PC2 and PC4. The result of the experiment will demonstrate that hosts within the same VLAN, such as PC1 and PC3 in VLAN 2 or PC2 and PC4 in VLAN 3, can communicate with each other. However, communication between PCS in different VLANs will not be possible as they belong to separate VLANs. Alright. Let's take a look at how the instructor uses Packet Tracer Simulator to complete this experiment. First, the instructor draws the topology structure by selecting switches and PCS from the software. The instructor starts by dragging and dropping a switch into the workspace. This is the first switch. Then, another switch is added to the workspace. Next, 4 PCS are selected from the terminal devices and placed into the workspace. The instructor needs a total of 4 PCS for this experiment. Now, the instructor connects the PCS to the switches using Ethernet cables. They click on the connection and choose the first switch, switch 0, for PC0 and PC1, connecting them to F0 first and F0 second interfaces, respectively. For PC2, it is connected to switch 1, and the same process is followed for PC3. Do not forget about the connection between the two switches. When connecting the two switches, we need to choose the interface on each switch. We will use interface F024 on both switches for this connection. If the connection is not correct, we can delete the cable from the interface and select interface F024 again. Then, we click on the other end of the cable and select interface F024 to connect switch 2 with the other two PCS. Let's check this interface, because later we will configure it. After the connection is completed, the next step is to proceed with the configuration. To do this, we enter the switch and select the CLI. Let's enlarge the CLI and press Enter to proceed. First, let's configure the left switch. Enter N to enter Enable mode. After entering Enable mode, we first create a VLAN and name it VLAN2. Then exit from VLAN configuration mode and create another VLAN named VLAN3. Once both VLANs are created successfully, we exit the VLAN configuration mode. Next, we proceed to configure interface F0 first. We need to configure this interface as a switch access port, allowing access to VLAN2. After that, we exit from its configuration mode. Then, we move on to configure interface F0 second. This interface is configured as a switch access port, allowing access to VLAN3. After configuring F0 second, we exit from its configuration mode. The last interface we need to configure is F024, which will be set as a trunk mode. After operations mentioned above, we exit from the configuration mode by typing end. In this mode, we can check the VLAN configuration. We can see that there are 3 VLANs in the table: VLAN1, VLAN2, and VLAN3. VLAN2 and VLAN3 are the ones we just created. With this, the configuration of the left switch is complete. Next, let's configure the right switch. The method is the same as the left switch. First, enter Enable mode. Then create 2 VLANs, VLAN2 and VLAN3, and exit from each VLAN configuration mode. Next, configure interface F0 first. Like before, we set this interface to be in access mode, allowing access to VLAN2. After configuring F0 first, exit from its configuration mode. Then, Proceed to configure interface F0 second. This interface will be set as an access mode, allowing access to VLAN 3. After configuring F0 second, exit from its configuration mode. The last interface to configure is F0 24th. As mentioned earlier, both switches use F0 24th for their connection, so we need to set this interface to trunk mode. After configuring F0 24th, type END to exit from the configuration mode. Similarly, we can check the VLAN configuration by using the show VLAN command. Let's check the VLAN configuration to see if it matches the design we made earlier. After verifying the VLAN configuration, we can proceed to configure the IP addresses and subnet masks for the 4 PCS. Without proper configuration, the PCS won't be able to communicate. Starting with the leftmost PC, we want to configure its IP address as 192.168.1.2. In the interface settings, we can assign the IP address and subnet mask. For this PC, we set the IP address as 192.168.1.2 and the subnet mask as 255.255.255.0. Next, we need to set the default gateway. Using the same method, we configure PC1 with an IP address of 192.168.1.3 and the default subnet mask. The default gateway for PC1 will be set to 192.168.1.1. With these configurations, the second PC is now fully configured. Next, let's take a look at the third PC, which has an IP address of 192.168.1.1, and the last PC, PC3, with an IP address of 192.168.1.5. Now, let's check if the configurations are correct. With the 4 PCS fully configured, it's time to perform the testing and verification to ensure that the desired outcome has been achieved. The desired outcome is as follows. PC0 and PC2 should be in the same department and should be able to communicate. And PC1 and PC3 should be in another department. We require that communication should be allowed between PCS in the same department, but restricted between PCS in different departments. First, we will test the connectivity between PC0 and PC1. To do this, we'll open the command prompt on PC0 and use the ping command to ping the IP address 192.168.1.3, which is PC1's IP address. After performing the ping test, we observe that all 4 data packets have timed out. This indicates that the ping test was not successful, and PC0 cannot communicate with PC1. Let's test the communication between another pair of PCS. OK. The ping command was successful, indicating that they can connect with each other without any issues. In conclusion, during the configuration process, please pay attention to the following points. Ensure correct interface connections between devices. Configure trunk ports between the 2 switches to enable communication between VLANs. Verify the connectivity between PC1 and PC3, as well as PC1 and PC2. This completes the process of configuring VLANs between the 2 switches.